Okay, great. Welcome back. We're on the home stretch now of this surface temperature observations lecture. We've now seen where surface temperature observations come from. We've seen all the safeguards we have to make sure the data are very high quality and aren't tampered with and all that kind of stuff. Based on all that, then, what do we actually know about what's happening to climate change? What kind of changes are we seeing in surface temperature? Well, I've got this figure here the author provides for, it's kind of like figure 2.2 in your textbook, although it's a slightly longer period of record there. But it's based on in situ temperature observations, and it's got the actual record in that thin line of the temperatures, global average anomaly temperatures over that 132-year period or whatever, and then also a 5-year smooth just to kind of get rid of the little peaks and stuff like that along the way. And obviously, I mean, you're not shocked by this at this point to see that there is warming. Right, over the period of the 132 years or whatever that length of record is, we've clearly had some warming. And in fact, the last decade is showing that it is the warmest on record. In fact, I took a different, this comes from the Washington Post, but just so you can see here, if we just do it this way, the darkest red bars there are the tallest 10 bars. Those are the 10 warmest years on record. And you'll notice that 9 of the 10 warmest years on record have happened since the year 2000. And the other one that doesn't fit the pattern is 1998. So it's not like it's all that far back. It happens to be the 1998 El Nino year, which was a weird year for climate for lots of different reasons. These global climate trends that we're seeing here, they're pretty big. If you look there at the top of the figure there, the trend from 1880 to 2014 had a trend of 1.17 degrees Fahrenheit per century, and just the last, from 1998 to 2014, we had a trend of 1.04 degrees Fahrenheit per century. Your textbook gives out another number. It says that for the last 50 years, the number is 1.3 degrees Celsius per century, which works out to 2.3 degrees Fahrenheit per century. Holy smokes. These are some pretty big numbers. That is a big climate trend. Now, we're going to get bogged down as to exactly how many, 1 degree different or 2 degrees different. Why does that matter? We'll do that later in the text in this semester, okay? So I was going to say that's a big trend, okay? Just so we're clear about this here, 1.17 degrees Fahrenheit per century, if you convert that to metric, that's 0.65 degrees Celsius per century. A better way to write that would be to change that per year. So we would divide that by 100. Okay, if that's how much it changed in 100 years, then we divide it by 100 to see how much it changes per year. We get 0.0065 degrees Celsius per year instead of per century. Notice, by the way, the symbol for per year is year to the minus 1 power. Okay, so we're going to be watching for that notation there where we got year to the minus 1. That means per year. Notice that the warming has not been all that continuous. There have actually been 2 periods where most of the warming has happened. One was about 1910 to about 1945, and then there was a second period from about 1976 to the present. Between 1945 and 1976, we had about a 30-year period there where there was actually very little warming. There's a lot of thought as to why that was. It probably had to do with a phenomenon that we probably will talk about, I think it's in the 4th module of the course, called global dimming. You've heard of global warming. Global dimming is a phenomenon where there was a lot of sooty pollution in the Earth's atmosphere, and a lot of the sun's radiation didn't reach the surface of the Earth to warm up the Earth because that radiation got absorbed and reflected by soot in the Earth's atmosphere. During the period from the 40s to the 70s, the Earth, people on Earth were burning a lot of very cheap but very dirty coal that pretended to put a lot of particulate matter into the Earth's atmosphere, and it's thought that the global warming caused by burning the coal and the greenhouse gases was being balanced roughly by the addition of all that soot and so on to the Earth's atmosphere. Whereas to some extent now the coal we burn is somewhat cleaner, so there's less soot, and we just burn so much more, and we have so much more sources of fossil fuels and so on, diesel and gasoline and as well, that now the effect of the global warming is winning out and temperatures are continuing to rise. But we'll learn more about that later in the course. I want you to know that the amount of global warming that we're seeing, the amount of climate change that we're seeing, does vary quite a bit by location. The bottom half of that diagram from your textbook shows the climate change in different parts of the world. The solid line is clearly the one that is going up the most, and if you read off to the scale there, you see that that is the northern hemisphere outside of the tropics. So from about 24 degrees north in this particular chart to the North Pole, you can see that there's actually been a lot more warming, in fact about twice as much warming as the planet as a whole in the northern hemisphere, in the mid-latitudes, and in the Arctic.
In fact, if I could just interject here, I apologize for the change in the audio and stuff like that, but I recorded this after the fact. I wanted to show you a little bit about how much greater those temperature changes are near the Arctic than they are in other parts of the world. This diagram here is showing the rate of temperature change from 1950 to 2014 in units of degrees Celsius per decade, and you can see that by far the greatest temperature changes have been happening in the Northern Hemisphere, and in particular at the Northern Hemisphere high latitudes, Canada, the Arctic, Northern Asia, places like that. But what I really want to draw your attention to is the difference between um, the units here. I mean, keep in mind that our global average temperature trend has been about 1.8 degrees Celsius per century, but these units are degrees Celsius per decade. So, like, if we have those those dark red colors are 0.5 degrees Celsius per decade, well, that would be 5.0 degrees Celsius per century. So that is a temperature change that's almost 10 times as great as the global average when we're talking up there in the Arctic, like north of, like northern Canada and Siberia and so on.
Now the next figure on the presentation here is just the temperature records from the satellite remote sensing observations over this period of time from about 1978 to the present. And what I want you to understand about this is that they're showing basically the exact same temperature trend that we're seeing from the in situ observations, both in terms of the global temperature and in terms of regional observations. If we took the time here to show you the trends seen by satellite over the Arctic are almost exactly the same as the trends seen by in situ observations over the Arctic. Or the trends being seen in the tropics by the satellite are almost exactly the same as the trends being seen from the in situ observations from the tropics. And this provides very strong confirmation of the reality of the warming trend. If we have two types of information and they're both telling us exactly the same thing, that is a very strong confirmation that the trend is real. Alright, well, it was the job of the Intergovernmental Panel on Climate Change to be looking at all this kind of information with all their different sources of information and all the different opinions of all the different kinds of experts and to synthesize that into their fifth assessment report, the AR5. What do they actually say about all of this? Well, you've read those pages, and I'm just going to highlight a couple of phrases that they used. When they're talking about temperature, they said, it is certain that global mean surface temperature has increased since the late 18th century. Certain. The book doesn't ever actually seem to define what they mean by certain. I mean, we know what we mean by certain, but just to be clear, certain is more sure than virtually certain, and they define virtually certain in the footnotes as being 99 to 100% probability. This is more than that. Okay, basically they're saying there's no chance that there's a mistake here. Notice that they actually are, in a very scientific way, putting error bars on their estimates. They're saying that since 1880 to 2012, they got a temperature change in that 132-year period of 0.85 degrees Celsius for the planet, but they're saying it's within the range of 0.65 to 1.06 degrees Celsius over that 130-year period. So see how they actually quantify now. Again, the business of how those errors are quantified, that's makes the stats major in me. You might remember I have a stats degree. That makes the stats major in me very happy, but we're not going to do that in a 100 level understanding science, not just core course, okay? Suffice it to say, there are well-established, well-published understanding of how to actually come up with error bars on something like a trend like this. Here's something else they said in that AR5 report. It is unlikely that any uncorrected urban heat island effects or land use changes have raised the estimated centennial globally averaged trends by more than 10% of the reported trend. First off, unlikely. They define in the footnotes what they mean by unlikely. They mean there's a 0 to 33% probability, which frankly seems kind of like a big range to me, but whatever. But notice what they're saying here. They're not saying it's unlikely that is there a 33% chance that there isn't such a trend? No, they're saying there's no more than a 33% chance that as much as 10% of the trend is due to problems with the data, due to inhomogeneities, due to things like land use change and urbanization. Okay, so they're saying there's not a particularly big chance that any of it is being caused by those sort of changes, but no matter what, it's not more than 10%. Okay, the observed temperature trend is due to problems in the data, inhomogeneities in the data. That's a pretty strong thing to say. It is very likely that the numbers of cold days and nights have decreased and the number of warm days and nights have increased globally since about 1950. Very likely. Again, I looked through their definition. What do they mean by very likely? They mean 90 to 100% probability. Okay, that is the level of certainty they have about that, based on consensus of the experts and things like that. Confidence is low for global scale observed trend in drought or dryness or lack of rainfall since the middle of the 20th century. What are they talking about here? When they say confidence, what they're saying, again, I looked at the footnotes and so on, by confidence they mean like the level of agreement or certainty. If there are some studies that say this and some that say that, we're not very confident as to what the answer is. Okay? Their confidence is low that there has been any kind of trend in droughts. That probably means that it doesn't seem like these droughts are becoming more common. That's kind of one of the stereotypes of global change, right? Like somehow or other the world is going to experience these droughts or something. They're saying that is at least not what we are seeing. Doesn't mean that isn't going to happen in the future, but they're saying that's not happening now. Finally, confidence remains low for long-term, that is centennial, like on the order of hundreds of years, changes in tropical cyclone activity. In other words, over the last 100 years or so, changes in the amount of hurricanes, or the strength of hurricanes, or whatever, our confidence in that seems very low. What they're saying here is, okay, one of the things that the public tends to think is like somehow or other global warming is causing more hurricanes. Well, that's actually a possibility. I mean, if you take ATS 113, you're going to find out that hurricanes are associated with the temperature of the water underneath them. A warmer planet should have, I don't know if it's going to be more hurricanes or stronger hurricanes, but something, okay? But they're saying, at least over the course of the last 100 years or so, we don't see that. Now, when you actually look at the statistics for the hurricane, notice they say, it is virtually certain that the frequency and intensity of the strongest tropical cyclones in the North Atlantic has increased since the 1970s. This is actually a big deal. From about 1975 to about 2005, the number of major hurricanes in the Atlantic skyrocketed. I mean, 2 to 3 times as many of them per year. They're saying that is virtually certain. That has happened. Whether that is going to be due to global warming and stuff, we're going to have to figure that out. There could be lots of reasons why we could have more hurricanes. So what they're saying is there doesn't seem to be a long-term trend on the number of hurricanes, like on the order of hundreds of years we're seeing more and more hurricanes, but there certainly has been a trend since the 70s, and that may or may not be related to global warming. Okay, that's the end of the lecture about surface temperature observations, but I want you to answer 2 more questions along the way, just kind of to help you get ready for the kinds of things that could be on the quiz. Question 8. Suppose the temperature increased in Omaha by 1 degree Celsius per century. Another way to write that would be A, B, C, or D. I'm not going to read all those numbers to you. Okay, choose one of the 4 answers, follow the link, find out if you're right.